Hello, everyone, and thank you for listening to the Fabrication Friday podcast. I'm your host, Joe Fairley, certified prosthetist, 3D printing enthusiast, and owner of Ascent Fabrication. Fabrication Friday is an all-around fun time where I talk about 3D printing applications, conduct interviews with industry leaders, and much more. Come join us every Friday for an informational discussion around the evolution of the additive manufacturing field and how we utilize various digital workflows and 3D printing methods in our daily work at Ascent Fabrication. Hello, everyone, and welcome to the Fabrication Friday podcast. I'm your host, Joe Fairley, owner of Ascent Fabrication, 3D printing enthusiast. Thanks again for tuning in to Fabrication Friday this week. Getting into the print of the week this week, we have a Van Ness rotation prosthesis here. A couple different parts to this prosthesis. We have a flexible inner component, and then there's a rigid frame. This is actually a project we're working on with a group out of Melbourne, Australia, working with ProMotion Prosthetics and Monique Vandeboom out there. So really cool opportunity to really show the power of the digital workflow and really, go across country borders to, halfway around the world to provide a different level of prosthetic care for patients. If you don't know what a Van Ness rotation plasty is, it's quite an interesting amputation process, actually. If you don't mind, maybe looking at a little some different configurations of body parts. Basically, what happens when someone maybe has a some type of bone cancer around their knee joint, particularly in younger kids, middle-aged kids. And what happens is they amputate just above the knee and then just below the knee. And then when their foot is still intact, they actually turn the foot in the opposite direction. And then your ankle joint becomes your knee joint. It's actually a pretty successful process that allows a lot of people a little bit more mobility with a more natural human joint for the knee, for flexion and extension, rather than having a prosthetic knee joint. So in some ways that can be a very useful amputation process. And for this prosthesis here, we have a foot section that is specific to around this person's foot. It's out of the VarioSure material from Color Fab. This foaming TPU is really, really nice to use because it's lightweight. The skin tones actually have an additive of silver in them. So having an antibacterial component to the prosthesis is a pretty nice addition as well. So the foot section here, printed on the artillery sidewinder in about 12 hours and 36 minutes and weighed about 140 grams. And we used a 0.6 nozzle for this. So there was a little bit of support material removal after that print. And then we also printed the frame for it. So what Monique is going to do there in Australia, once these are all shipped to her, she's going to actually fill the frame with plaster and then end up laminating around that plaster mold to have a carbon fiber laminated socket for the outer frame for this flexible inner socket. So same kind of deal with the thigh. There is a thigh section here that was printed with a 0.9 millimeter nozzle on the Filament Innovations Kratos machine. That was printed in about 7 hours and 45 minutes, weighed about 202 grams. And then the frame out of PETG again in an hour and 38 minutes and 370 grams. Should have mentioned too, that foot frame was an hour and 23 minutes. So doing vase mode printing and with a 2.5 millimeter nozzle for those frames, very, very quick results for the high flow Filament Innovations machines. So that is our prints of the week. Really looking forward to seeing how that's going to come about with the patient and see what she thinks of it. And now getting into our Fabrication Friday podcast today. Hello, everyone. Thanks again for joining us for the Fabrication Friday podcast. I'm your host, Joe Fairley, 3D printing enthusiast and owner of Ascent Fabrication. And with me today, I have an awesome special guest who is probably more of a 3D printing enthusiast than I am even. So Mr. Zach Burhop, I've been following him for quite some time on LinkedIn primarily, just found his Instagram as well. You're printing some really cool things, man. I just wanted to kind of get, a little bit of background on, how you got interested in the 3D printing industry in general, and maybe about a couple of the positions that you've worked in the industry.
Yeah, definitely. Thanks for checking out all my posts. Like it's nice to see people looking at it. A lot of work and thought kind of goes into that. So it's nice to hear that it's not, just going into the black hole. I've had kind of an interesting entry into 3D printing. I've been in the industry for about 10 years. I think I was one of the last generations to grow up and go all the way through college without really having a lot of access to 3D printing. So a lot of my early background was, trying to build a lathe in the garage, almost, throwing a tool through my dad's car window,
Sure.
that kind of thing, trying to get access to CNC machines or mills and things. And it was really great, kind of early, like when I graduated in like 2011. That was right when MakerBot was really huge. A company called Solid Doodle out of Brooklyn released the first printer that was under $1,500. So I had kind of been aware of the technology, but it was a really cool idea to be able to make parts for the first time without having to do all of the subtractive manufacturing. So I took all my graduation money from college and I bought like a Solid Doodle 2 machine. So first machine was about $1,500. It looked like, something somebody built, on their own. And it's just crazy monster Rube Goldberg kind of machine.
Okay.
And I remember setting it up and then sending my first print to it that I designed. And it was like one of those magical moments out of like a movie or something where like this moment is like going to affect, what you want to work on for the rest of your career. And that was very much that for me. So I basically took this printer and I just started printing, and it's been kind of all additive all the time, after that.
Yeah, very cool. So Solid Doodle, I haven't heard of that company yet. So what did that look like?
So it was just a solid metal riveted frame.
Okay.
Basically, there was a guy named Sam Cervantes who briefly was on the MakerBot team before they were acquired by Stratasys.
Okay.
And he left there and he started this kind of Brooklyn startup called Solid Doodle. And it was basically a race to the bottom. So you had the around $3,000 MakerBot, and they were trying to really undercut their price. So he had this kind of cool sheet metal frame that you could stand on that was kind of all riveted together.
Okay.
It was back before E3D. So you had this crazy hot end that was like coated in epoxy and then wrapped in Kapton tape. And it was just this kind of crazy machine. But it printed. It had a 6-inch by 6-inch bed.
Okay.
Which is crazy,
Yeah. For back then.
Yeah.
That was definitely a pretty big build volume back then. Yeah. I recently saw one of your recent posts about one of your other early on printers. Was it something from Ultimaker, one of the wooden ones?
Yeah, so I kind of cheated. That's a MakerBot Thing-O-Matic.
Okay.
That was the printer that I always wanted. But honestly, like at the time you just graduated from school, it was too expensive.
Okay.
So I always wanted that machine, and that's like the machine that really got me thinking about 3D printing and like really excited about the industry. So a couple years ago, I always am on eBay for like weird 3D printing stuff,
Right.
and I saw this like pristine MakerBot Thing-O-Matic. It was like one of the very few models that was assembled on site in like the early days of MakerBot.
Yeah.
And it had an automatic build platform. So like you would see now, like the conveyor belt style platforms that can produce. It actually was doing that way back in 2010, 2011.
Okay.
So I was able to find one of those, and I bought it. So I pull it out every now and then. It's just this great piece in my studio.
Absolutely. How many printers do you have currently?
Are we counting working or non-working hours?
Let's go non-working. I probably have a couple in the graveyard here too.
Yeah, I probably have close to 12 if we're counting capable of printing at some
Okay.
point in its
Nice.
I lately I've like really focused on the bamboo. I think like the Bamboo Lab printer is an amazing machine.
Yeah.
But I also recently added an Entamsys fun mat to be able to continue to do like a lot of really high temp printing, Ultim and Peak and
Right.
those are like engineering materials.
Right.
I always keep an Ender 3 because I love the ability to modify that printer to be whatever I want it to be, which is really
Sure.
cool. I've got one out there printing chocolate right now. I've got
Excellent.
another one that's about to be modified for the Revo nozzle high flow
Nice.
system.
Nice. Awesome. Yeah, chocolate printing is pretty fun. I recently I've been watching Cocoa Press quite a bit and seeing what they're doing. They're now actually coming out with a starter kit, builds part of the printer. I think it was like 1,500 or something around that. And then there's going to be like a second launch of fully assembled printer for a little bit more, but that'll be my first chocolate printer. Do you have any tips on chocolate printing when I get that?
Do they have active cooling yet? I've seen that machine a little bit.
I don't think so. So I think it's just a chocolate that will cool at room temp and printed cold enough that you don't need any extra cooling, because I don't think there were any cooling fans on that. Although, obviously you could attach one and maybe use different chocolate with it, but they're trying to make it like as plug and play simple as possible.
Yeah, so it sounds like they've done like a little bit of process work with the actual chocolate itself too.
Yeah.
I most of the chocolate printing that I've been doing has been off the shelf, like high end baker chocolate.
Okay.
And there's been a huge amount of like process as far as like tempering the chocolate. You need to get it to like a certain temp and cool it pretty quickly, and there's a lot of neat process things. But cooling has been big for me. I find that I can't, like, I have a fan, but like you almost need like a chiller or something to like blow air.
Right.
I've got it to work best in the winter. And essentially I'll take my air conditioner and I'll just shut the air conditioner off for a few hours, and I'll bring the temperature of the house like really low.
Yeah.
And then print. But that's been the biggest struggle with chocolate so far is that. It's like almost like fans aren't quite enough. You need some like chamber or some kind of like chilling system.
Yeah. I think so Cocoa Press had one version earlier of their printer, which was it was a more industrial looking machine. That was like something you would definitely see in a chocolate shop, where it looked like a refrigerator, open the door, glass door, and there was the printer inside basically. Because I think they had that, same thought that, having that just forced air wasn't quite enough, and then needing that chilling for the different viscosities of different chocolate to cool quickly enough. So,
It's an exciting area. Like I remember going to CES maybe 2015 or so in Vegas, and 3D Systems would have their candy printers out. And I always thought that was so cool because they were doing like lattices and like like a tiny gumball that had this like complex geometry, and it was kind of like a sour flavor. I always thought that was like the coolest thing. Like I would love to get into that sometime.
Yeah, they're just melting down that sugar in a certain way, right, and cooling it again. I mean, is it any different from filament or chocolate printing like that?
I don't know. I don't think it was an FDM based process. I think it was more, I think, similar like a powder bed kind of scenario.
Wow.
Because it was like a granulated powder that they had that they were solidifying.
Okay.
So like that was allowed them to do like really, really fine details on like really small things.
Oh, that's
so
cool.
you take a gumball and then you apply like a lattice to it, and it's this beautiful piece of art. It's incredible.
Awesome. That's awesome.
Yeah.
I wonder how much that one gumball costs to print.
Oh yeah, I don't even want to ask. Like it's one of those like if you have to ask, you can't afford it kind of thing.
Right. they're doing it for the wow factor and to show what's possible, right? But
Yeah.
other than that, it's just a cool looking gumball.
Yeah, exactly that. Yeah, and so the chocolate stuff is really interesting because it's, it's a more economical way of getting into like the food printing kind of
Sure,
thing.
sure. So, I mean, food printing, they're now starting to print some meat, whether it's meat or, non-meat, vegetable-based meat. How would you think that's gone about with the actual materials they're using and then trying to solidify something like that? I mean, do they even really need to solidify it because you're then cooking it afterward, right?
Yeah, sometimes I think projects go too far with additive.
Yeah,
It's like it's a useful technology, but it's definitely like a tool in the toolbox.
right, right.
When it comes to something like meat, you hit it exactly on the head. Like if
Yeah,
you're gonna cook it, like does it really matter at that point that it's 3D printed versus
right.
molded or you know?
Yeah. I mean, what kind of advantage are we getting by 3D printing it versus just getting it otherwise? I don't know. Um,
Yeah, I mean, at a certain point too, like 3D printing is still like a pretty big like marketing ploy too. So it's very
yeah,
easy to say, hey, we 3D printed it. Check out our company.
right. Just a
Super
wow
much.
factor, right?
Yeah.
What's the most fun thing that you have printed? What's your favorite piece? If you could pick one, maybe two, it might be kind of hard, but
Yeah, that's actually a really difficult question. I did one recently that back before the Stratus acquisition of MakerBot, they were generating a lot of really cool models. They were kind of exploring what it would be like to sell like models as a company that you could build. So one of the ones they did was this dinosaur, and I'm sure you've seen it on like Thingiverse over the years. It's a T-Rex, but
yep.
people have done like all this remixing. I saw the other day like they made the dinosaur skull into like a shower head that
Oh
would just
my
spray
God.
water. It's
Okay.
crazy.
That's nuts.
But originally it started off as a full T-Rex skeleton, and they actually employed a sculptor to kind of come through and make it in such a way that you could 3D print it.
Okay.
So I've always wanted to do it, and recently like a Centium, the local company in Austin,
Yeah.
um, started making all this other company called 3D Fuels Filament in house. So it's right down the road from me. So
Yep.
I was really excited about the idea that my filament is coming from 20 minutes down the road.
Right.
I grabbed a whole bunch of it that was made locally, and I printed a like a really big T-Rex dinosaur, and I think I posted about it too.
You did.
But basically, I scaled the skull so it would be the absolute biggest build volume of the Bamboo Labs 3D printer,
That's
and
awesome.
then I kind of let all of the other parts kind of follow behind and scale.
Yeah.
So a lot of them ended up being a little too tall, and I had to like do some kind of clever like mesh work and stuff to try to like get them all in the bed. But I ended up with this like 7 foot long T-Rex skeleton. It's like 3 or 4 feet high,
That is
and
awesome.
that was cool.
That's awesome. Is that now like a corner piece in your house? Just like as soon as you walk in, this is greeting you.
Yeah, I've got it hanging. Like that was a funny realization. Like I
That's
printed
awesome.
this thing over like 3 weeks, and then all of a sudden you've got this giant dinosaur, and you're like, what the heck am I gonna do with this
What do I
thing?
do with this? Yeah, is it going on the
Like, where do
roof
I
or
put it?
something?
So my design studio, I ended up putting a couple hooks in the ceiling and like suspending it just because like I had no floor space for a 7 foot long dinosaur.
That is awesome. But maybe there could be someone's looking for, printed dinosaur bones somewhere, maybe for, an art museum or something like that.
Yeah.
I love finding like those practical uses for 3D printing, as I, can definitely tell you do as well. So for that case, you definitely have maybe a little bit of a market there for 3D printing some, dinosaur replicas.
Yeah, that would be really cool. I always think like I'm really interested too in like a lot of the bone trainers and things for surgeons and things. They
Yeah.
have a lot of really cool like materials that are kind of like bone simulants that you can
Right.
still have to print. So I
Right.
always thought that would be a cool thing too to kind of play with that. But
For sure. Yeah, I know there is actually one company. I forget if it was FDM based or another process, but they are making a material that is as close to similar as bone.
Mhm.
You know, that's definitely, you know, when we talk about materials, you know, when we want them to be looking and feeling the same way as something we would want to work on. You know, I'm seeing a lot more companies pop up that have like these more, you know, very fine-tuned and niche, you know, spaces even within the 3D printing industry, right?
Mhm.
It's just like one niche group after another that just kind of blows up in its own way. Um, you know, like concrete 3D printing and all the different you know, structures that they're building with that, homes and other structures, trying to 3D print bridges in Amsterdam and stuff like that, you know.
Yeah. That metallic bridge in Amsterdam is beautiful. I'd love to go walk across that someday.
Oh yeah, I was there just a couple years too early. I got to
Oh man.
tour Ultimaker's headquarters back in 2016, I think it was. Uh,
Uh-huh.
when I was doing some work with them on a kind of a mission-based trip to Haiti, actually, and for prosthetics. But we got the chance to go and tour their facilities and then learn all about their Ultimaker printers. But I was just a couple years too early for the 3D printed bridge, so I'll have to go back to Amsterdam sometime and check that out.
Yeah, that's cool.
Yeah. So you've worked with a couple different companies in the additive space, right? Could you kind of take us through, you know, were you seeking out those additive manufacturing industry career paths, or did that just kind of come onto you?
Yeah, so talking about way back in 2012, I get my first printer. I'm still doing engineering work, so I at the time I was working for a production company doing TV for Nat Geo. But I basically was going home at night and then just doing as much basically application and process work as I possibly could with my 3D printer, and I knew that's where I wanted to go. So I was pretty lucky. In 2013, I started working for a company in Las Vegas. So I was in Atlanta at the time, and I moved all the way out to Las Vegas to work for a hotel billionaire who who made his money in real estate, hotels, things like that, and was always very interested in space. So in '99, he licensed a bunch of technology from NASA for inflatable space stations, and he started this company. So I joined up in 2013, and shortly thereafter, I took over all additive manufacturing on site. So we had Stratasys machines, we had tons of MakerBot consumer level machines. We were essentially like an R&D team that was envisioning what it would look like to work in deep space, or kind of in areas of space where it was really difficult to bring supplies to and supply missions. So we did lots of mock-ups, lots of prototypes related to like life support systems, and that was all being run through the additive section. So I was there for about 8 years, and one of the really cool things that we started really paying attention to was the ability to 3D print in space. So I did a bunch of work with a program called NASA Next Step, where they were essentially looking at, okay, if we send a deep space mission out or we send a mission to the moon, what would that environment look like? So one of the projects there that I spearheaded was the manufacturing center, and kind of looking at what it would take to build things in space, what types of parts on our inflatable spacecraft could potentially be printed by the astronauts. What kind of tools would they print?
Yeah.
Form factor would the machine be in? So I was there for about 8 years, and that was a lot of like really, really cool additive projects. But it was always really interesting to me that like my ability to work on that all very much stemmed from that $1,500 printer in
Yeah.
2012.
Well, that was a lot more, you know, experience than a lot of people had back in 2012, 2013 as well, right? I mean, people were still figuring out from a Stratasys level down to consumer how to even use those consumer printers, right?
Yeah. Yeah.
You know, if those were simply for prototyping stage versus a Stratasys printer that would be used for production status, right? So that's pretty neat to hear. I mean, printing in space, what kind of things came up, right? Obviously, no gravity, so you're kind of forced to print inside of something else, like a container of some sort, or how would you go about that?
Yeah, so it ends up not the zero gravity thing ends up not being is especially with FDM, which was my major focus.
Yeah,
Not as big of a problem, I think, as you would imagine, right?
yeah,
Uh, you can see even printers on Earth are capable. Like you can turn them upside down and mount them on a wall and then print,
right.
vertically. So that was fairly like an easy problem. The big problem that we would face is that you're really controlling your environment space. So it's not like Earth where you have like good airflow and things like that.
Mhm.
Every single thing that you're bringing up to something like the International Space Station is going to stay there unless it's removed by some kind of technology.
Right.
Um, so most spacecraft have an environmental life support kind of control system that's removing things from the air like ammonia that your skin emits, and all sorts of things like that.
Mhm.
So you would basically build these 3D printers into an entirely sealed environment.
Okay.
NASA's very concerned about particulates escaping, and then you'd be able to breathe them in.
Right.
So there's all these different form factors on the International Space Station for mounting what they call glove boxes, or these little sealed experiment boxes.
Okay.
So everything that we designed to print in space, all of the machines would be totally sealed, and you would basically be removing the air from those boxes, as you're printing. But it was really interesting at the time. Space, it was $10,000 a pound to send anything to space.
Wow.
Um, so it's
Yeah.
really interesting. Like, if you can send a big stack of material that could be, 1,000 different things if you wanted to,
Right.
versus sending one particular wrench that's designed to do one particular thing. That's a huge thing for them.
Sure.
So that was very cool.
That's so neat. So, like, what kind of materials were they trying to send up there?
Yeah, so the biggest polymer that gets used right now is a high temp material called Ultim 985. It's a PEI based material.
Okay.
They really like it, and it's far easier to certify than anything else because it doesn't off gas, so it doesn't produce dangerous chemicals,
Okay.
as it lives its life. It's also fire retardant, which is a huge thing in an oxygen rich
Sure.
space environment.
Yeah.
So you see, like most of the additive, there's a lot of really cool additive projects that have gone up to the space station, and they're primarily out of Ultim 1010.
Okay. Yeah, I've definitely heard of Ultem, but haven't seen like any practical parts in person printed out of them. So I can't quite wrap my brain around like what kind of different things would you print with Ultem? What are some considerations on the design end of things for like what would you want to print with Ultem?
Yeah, so one of the interesting things, Ultim can be difficult to print. It prints in a very hot environment. So you
Okay.
usually need a chamber between 100 a chamber temp of between 100 C and about 200 C. And
Wow.
and some machines print even as high as like 240 C.
Wow.
You're going to have about a 200 C bed, and then you're going to be printing at nearly 330 to 400 C at the nozzle.
Yeah.
So it's a very, very hot material. But it's got a lot of really good advantages. Like we were talking about, it's totally fire retardant, which is huge.
Right.
Uh, doesn't outgas. It's about a third of the strength of aluminum, so it's very, very strong material for a polymer.
Okay.
So it's a really well suited material for things like tools. So like wrenches with specific torque factors. So NASA's big, like the first thing NASA ever 3D printed really in space was a wrench that had a specific torque value attached to
Okay.
it. And it was really cool because they emailed it to space and then they printed it.
Yeah. That is so sick. That's awesome.
Yeah.
Oh man, getting the chance to send a file to space to print. I mean,
Yeah.
that's kind of the end goal here. That's the dream. Like, can you have that kind of impact of, sending things that just into space. I mean, that's blowing my mind right now. That's so cool. We send files all the time, like across the country, maybe to country, around the world, but going out to space, that's a whole different ball game. That's so cool. So you got,
Hey, I would have been loved to have been the guy that like sent the email. And I probably would have like CC'd all my friends too at the same time.
yeah, and like screen recorded it and like shown it live and
yeah.
those things to get the hype up about it. That's awesome.
Any job interview I did ever after that, I would just be like, yeah, I sent an email to space.
Yep, that's on your resume first and foremost. Like, what job qualifications do you have? Well, I'm on the space station speed dial for parts. So yeah, that's pretty sweet. Very cool. So you had would we recognize any of the names of printers that went up to space, or not so much?
So there's been a lot of experimentation. So the ultimate dream for NASA is to be able to have a high temp printer in space that they can then take the parts and then they can run them through a something that breaks the parts back down, and then they can be able to run parts from those recycled parts.
Sure.
That's the absolute dream. So there's been a lot of experimentation. There's a company called Made in Space that has really led the way with printers in space. So primarily they've been testing most of their hardware. A couple years ago, they were acquired by a company called Redwire, who's continued to kind of support them.
Okay.
But it's really neat. They're totally built. So there's a glove box system that they use on the International Space Station. Kind of think of like a server rack. It's a general purpose standard that you can send anything. So, for example, another company created a fridge, like a freezer that could go to space to hold specimens, and it's called the Polar Freezer. But it's designed to fit this server rack essentially, so it can go up. It's got predetermined power, like a certain voltage, certain bolt patterns, and they just plug it in, snap it right in, and they can do the same with experiments and new technology. So most of the printers that have been going up right now have been designed to kind of fit that general rack mount system.
That's pretty
which
neat.
is really cool. My big thing, so the NASA Next Steps program. So I was our subject matter expert for additive. So basically, we designed a general mock-up. So what you would call a glove box. So it's you've got a 3D printer and then you've got a glove box, and the glove box is basically a sealed environment that you could do like post-processing it. So if you're trying to remove flashing from the printer, you would take the part out of the printer, put it in the glove box. You'd put your hands in these gloves, and then you would go ahead and remove flashing or any sanding that you need to do, things like that.
Right.
So we essentially designed a high fidelity mock-up that presented a 3D printing space and then this post-processing station. So it was really cool. Like we actually mocked up the entire giant inflatable spacecraft. So it had everything in it, from toilets to work areas to exercise areas.
Yeah.
And we had four NASA astronauts came to our facility, and they basically lived in our mock-up for a week, and would go through their normal day like they were on the International Space Station. So we would be mic'd in to the astronauts. I designed a bunch of experiments. They would go to the Additive Manufacturing Center, and then they would basically go through what it would be like to print a part and to post-process a part and then to install a part. So that was really neat to get a lot of like firsthand experience on what the astronauts are expecting. All of these astronauts had been to space. One of them was even the first on the first SpaceX launch, the man launch to the ISS. So that was really cool to see, and get their feedback on how that would work.
That's pretty nuts. Yeah, I guess they have to, do quite a bit of practicing before they go up there, right? And if you're able to walk through your daily life, including the printing, that gets rid of a lot of those variables that right off the bat that, when you send it up there, that it's going to work, right?
Yeah, definitely. And for astronauts, they're very process oriented too. So Their time from a monetary perspective, their time is extremely valuable.
Sure.
So very few things are left to chance. There's usually really well documented steps of what they need to complete and what they need to do. So
Right.
it was really neat to kind of flesh that out, before sending something like that.
That's really neat. Yeah, to have
Yeah.
that experience. And I got to visit NASA down in Florida when I was younger, and just kind of, had that initial wow factor of like what kind of scale you're working on, right? Of these ships that are going up, the overall space station size, and kind of like what all those different things that they're going to be doing during their lives up there. Few months to maybe a year or something. Having
Mhm.
that kind of time with them before they go up there. And so did you have to, then have any talks with them while they were up in the space station? Did they go up after that and then continue working with them?
So most of our projects were kind of forward thinking. So they were very R&D oriented.
Yeah,
So this would have been stuff that didn't immediately go up or get tested.
gotcha.
Uh, it's amazing. Like when you start working with a lot of the space programs, there's so much pre-planning and so much R&D that goes up before they ever even do like a small experiment.
Hmm.
Uh, so what we were doing primarily was kind of things that are going to be potentially implemented in the next 10 to 20 years.
Okay.
It's definitely stuff that is beyond the space station. So say you're going to the moon, or you're going to Mars, or you're
Right.
going out in deeper space. We were trying to tackle a lot of those problems that those guys would get, because the International Space Station, I mean, they get supply missions all the time.
Right.
Something breaks, you get a spare part. And when you're that far out, obviously you're not going to get spare parts all the time. You're going to
Right.
have to do a lot more, design and modifying things and printing things,
Yeah.
which is really cool. That'd be my dream job. If they ever wanted to send me to space, just sit on the moon for the last 30 years of my life, design weird parts.
Yeah.
That'd be
That
great.
sounds like a pretty good job gig. I wouldn't mind that. Yeah.
Oh, it's my retirement plan. I'm like hoping, like when I'm 60 years old, like I don't care. I'll take the one-way trip. I'll just design stuff all day and
Yep.
be yeah.
That's awesome. That's awesome. Yeah, I know there's one company that I was looking into recently that's already in the concrete printing area called Icon, or Icon Build, something like that.
Yeah.
And
The for house printing.
yeah, and they're
Yeah.
looking to print houses on the moon and other structures on the moon. They're looking to just put their printer basically folded up and put it on a rocket and just send it out there, and then it gets dropped on the moon. A couple of landing feet come out, and then the rover that it's attached to goes to its pod that it's going to start printing. I mean, that just kind of blows my mind that we're thinking about just sending up that scale of a printer as well. And then the second question that comes to my mind is like, okay, well, what materials are we going to use on the moon? Are you going to bring materials up with you? Are you going to try to source material from the moon or something? Have you seen what Icon's doing?
Yeah. So I'm in Austin, Texas.
Yeah,
Icon's located in Austin, so they're down the road from me.
awesome.
So I got a couple of funny stories about that, but yeah, it's really neat technology. And in Bigelow, we were looking at a lot of that too. Essentially, the rock material on the moon is called regolith, and that's what you would end up using to build structures. It's
Okay,
just too expensive, and it's too resource heavy to bring anything to space. You
right,
really are going to need to a successful operation is going to use what they have available.
right.
So there's all sorts of really interesting concepts. We were essentially not looking at an additive, but because we make these inflatable modules, we were looking at basically packaging the moon material into sandbags to help like shield you from things like radiation and to provide insulation. But I've seen a ton of really cool concepts too, especially like Icon,
Yeah.
where they're using the regolith as an actual printing medium. So they're building essentially a space cement, material,
Right,
and they
right.
print it.
That's insane. That's insane. So have they tested some of that out yet? Do you have any idea if they have like brought material back from the moon and used some of that regolith, or are they just kind of conceptualizing that as a process right now?
So they have, obviously, during the Apollo program, they did bring a lot back, and they did study us. They have a really good idea of what that material is.
Yeah,
So for that reason, that there's tons of companies out there that produce simulant.
gotcha.
So they especially use the simulant for things like rovers testing, when they're trying to test their rover wheels and like the things they're going to send to the moon.
Okay.
Um, but they are currently working with NASA, and they are printing with essentially simulant,
Okay.
which is really interesting. The other side of it is
Yeah.
they're actually printing houses from cement in Austin.
Right.
Uh, there's one of my favorite coffee shops is downtown Austin, and I'll get a coffee sometimes, and I'll go for a walk. And I'm like walking through this neighborhood near this coffee shop, and I see a gantry, and
Yeah.
I'm just over a fence, and I'm like, I think that's a 3D printer. Like,
Yeah.
I'm pretty sure that's a 3D printer. So I
Yeah.
go kind of like peek through, and that ended up being the site. So they call it House One. So if you're
Right.
really curious about it, look up House One.
Yeah, I've seen a couple of videos recently just over the past couple of weeks, and I've gotten really intrigued by it. My wife and I are looking to try to buy a house here in the next year or so. And I'm like, well, honey, can't we just, print one instead?
Yeah, and it kills me though too, because they're still so expensive. That's like a multi-million-dollar like house. And
Right.
I love to live in a 3D printed house.
Oh yeah.
And
Oh yeah.
you see all the videos about like oh, this is gonna be low cost, and we can do houses for the homeless. But it's frustrating, because then you go and you look at the houses that are actually for sale, and it's like, oh, this is a $2 million house.
Yeah.
It's crazy.
Yeah.
But it was really funny, because that House One, I caught it really early, so I would go for a coffee every week, and then I would kind of like document their process as they built it.
Yeah, that is so neat. I've seen the few YouTube videos where they're showing it off to a couple different companies, and
Yeah.
they're looking at the inner structure, talking about the process of printing it. A lot of people ask, well, can you hang stuff on the walls?
Yeah.
The layered concrete, but it's so neat to see, all these different applications for 3D printing, because there are so many applications for it, and
Yeah.
it's kind of up to people like us sometimes to show people what's possible, right?
Mhm.
uh, that's kind of been my driving factor with Ascent Fabrication and getting into some different things now, is that you can print so many different things, and just thinking about that, design and how you're going to print that thing, right? uh,
Yeah.
so I've been trying to help, other people recently focus on like, what is design for additive manufacturing? How do we think about these things to actually print well? And what materials do we use? What printers do we use? Um, on the low end and on the high end, I've got on the low end here, the Artillery Sidewinder X2. On the high end, we've got the Filament Innovations
Mhm.
Kratos, and we service the Icarus as well. You mentioned belt printing, so we're into the black belt printer too. Have you seen the black belt?
Yeah, that's been like a hugely successful printer from the prosthesis standpoint. People really seem to love that.
The black belt printer?
Yeah,
Yeah.
I've seen several kind of prosthesis companies kind of really adopt that. So that's really cool.
Well, when we start to get into like the production level too, right? It's,
Mhm.
how fast can we get some of these devices out there? And again, how do we print them with different printers? Um, you mentioned that also. So from Bigelow getting into you had another 3D printing company, right? Um,
Yeah. So Bigelow was interesting during the pandemic. Mr. Bigelow, the hotel billionaire, was funding our entire company out of pocket. So for a billionaire, this was his hobby. And
sure.
when the pandemic kind of struck, things kind of suffered, and he decided that it's time to back his hobby back a little bit. So he shut the company down.
Okay.
And so after that, I immediately almost went out to Houston to continue working in space. But I had kind of realized that I had done space, I had worked with astronauts, and I didn't feel like there was growth that could happen. It was just going to be another project, or another one. And I decided, like, my favorite part of my day was working with printing, and especially working with other engineers that maybe like weren't used to DFAM, or like their ability to do that,
Yeah.
or to design for 3D printing. And that
Right.
was like my favorite thing to do, was to help people kind of get their vision out in a way that made sense for additive. Um, so I looked specifically to work for a 3D printing company, and that's when I found Ascentium, and here in Austin. So I moved from Vegas to Austin, and went to work for them. And essentially, Ascentium started off as a materials company. They had a bunch of different phases in their life, and then they eventually branched out to an industrial sized printer that would compete with things like the Fortis 400, except they didn't limit the material that would go in. So you had full capability to turn all the levers, to use whatever material you want, create your own processes. And it was a really interesting, take on it, because prior to that, since the 80s, Stratus has owned FDM. I mean, that was the company, right?
Right.
So that was really neat. So I worked with the machines and kind of next level prototypes, and then I also worked with all these great materials that we invented in house. So we did a lot of like engineering grade materials. So we didn't focus as much on like the PLAs and the ABSs.
Sure.
We did a lot more nylons and high temp nylons and carbon fiber nylons. We did a material that called PPE SCF, which is kind of a metallic-y kind of polymer. We did Ultims, and we did PEC, and we did PEEK, and all these just very performance materials.
Yeah.
So it was really a really neat experience, kind of to get to play with all these technologies.
Yeah, I feel like there's so much to be done on that high end as well, with those machines, and making them even more useful for other companies that aren't just Stratasys size, maybe.
Yeah.
Getting down to kind of the middle level companies, and for them to be able to help bring some manufacturing back to the US, and have a lot of this stuff done in house now. You mentioned one of your favorite filament companies coming back and being local to you. So with what Ascentium has kind of started on the very high end of things, how were they starting to use it? What kind of industries were they in? And because I know that they were involved a little bit in the prosthetics orthotics industry early on. And one thing that I remember back from probably around that 2015 2016 timeframe, they were trying to use microwaves or something like that to help solidify the Z bonding interlayer adhesion.
Yeah. So Ascendium was a startup. That's like fundamentally they weren't
Right.
to the size of something like Stratasys. So they were definitely attempting to find uses in additive wherever we could absolutely find uses. So that was one of the projects. I didn't specifically work on that one. It's called Flash Fuse,
Okay.
and essentially they're trying to get. The idea is that you're trying to get closer to the strength of an injection molded part,
Mhm.
on the Z bonding. So your weakest point
Right.
is going to be where those layers are trying to adhere. So
Mhm.
the idea is that you use heat, or you use electrical arcing to essentially fuse those layers together.
Mhm.
And that's a project that I think it's still ongoing for them, trying to really get get all the details ironed out. That would be, I mean, huge for the industry as far as
Sure.
making injection molding like parts, right?
Oh yeah. Yeah.
Um, but application wise, we were all over the place. So that was particularly my job, and I was kind of on the advanced application side. So we were trying to think of what people could use our materials for in the future, and we were kind of agnostic to industry. It just we were trying to find the best use of our materials and or our 3D printing technology that we possibly could, and it's wherever we could provide value. Was important to us. So we did a little bit on the prosthetics industry, kind of designing foots and things like that. We did some really interesting testing around that. it was a really cool like R&D environment too.
Yeah.
So that was neat.
That's pretty cool. Yeah, I know with they were looking at prosthetic sockets at one point, and I think again they're still kind of sort of in the prosthetics industry a little bit. I did see a 3D printer from them, the HS whatever, maybe HSE something or other, at one of the conferences in prosthetics or orthotics. I think it was not last year, but the year before maybe. And they had the printer there. They were mainly printing, I think, just maybe PETG, for prosthetic test sockets, and looking at some of those carbon fiber nylon blends actually too. I saw probably one prosthetic socket that was printed by that too. And just to have that at scale, they're in this prosthetics orthotics industry at a conference. I mean, people were, oohing and ahhing over it, all over the place, because, our industry has never seen that kind of technology too. So it's pretty neat to see, all these different companies who are, again, looking for applications, wherever to use what they have going on.
Yeah, it's an interesting, the industry is kind of interesting right now, because you've got such a developed like consumer printer space, and then you've got the really high end stuff. So I feel like the way of thinking for people now is like either I'm doing PLA or I'm doing metal. And
Yeah.
it's really not the case. It's like there's this huge spectrum of high performance materials that fill in the gap between metal and something like PLA.
Right.
And I think it's that I'm like really excited about companies that are really delving into that kind of high performance area, because it's I mean, they're high end. I mean, they're not cheap materials, and they present significant amounts of strength, and they're all there's a ton of great materials for specific uses. Whether you're making molds or sockets or bracketing, it's a
Sure.
really neat space to be in.
Sure. Yeah. I again, with looking at how we're getting more and more outside of the prosthetics to orthotics industry as well. I love, again, trying to find these useful cases in our everyday life for 3D printed parts, right? And finding that right material is part of that. I wanted to highlight your one of your recent kind of fun prints, the mailbox that you just made. I thought that was so cool. Can you take me through a little bit of that, like, design thought in your head, and like what materials were printed out of it? What printers did you use?
Yeah. So that was kind of an interesting project. So I'm always looking for problems. I find that's the hardest part sometimes about, creating these additive projects, is you want to find a really cool problem that you can easily use the technology to solve.
Right.
So that's what I'm always on the lookout for. So in my case, I had a mailbox that was, almost, falling on the ground. So I needed to change something. We were talking a lot about Ascentium at the time, about UV resistant materials. And I find in the industry in general, there's a lot of misunderstanding on to how well materials do out in the sun. So if you know anything about Texas, Austin, Texas is as hot and sun heavy as you're ever going to get.
Right, for sure.
So it seemed like a great opportunity to get some like really hands-on ideas of how materials are going to work. So I started designing this mailbox. I wanted to print the entire main mailbox structure in one single piece. So I was specifically targeting, at the time I was working at Ascentium, so I had access to an HSE 180, which is a really big, high temp, big giant build platform industrial printer.
Right.
So I definitely targeted that for printing the main body.
Okay.
And then the whole idea, I kind of used my experience in space travel to kind of to inform my general design.
Sure.
If you look on the outside of something like the space station, there's all sorts of experiments that are like on the outside. They're just bolted to structures and things, like maybe material coupons, and they're testing how well it does out in the vacuum of space, things like that. So I wanted to design a mailbox that you could really you could bolt an experiment onto, or if I wanted to do a solar panel, I could bolt the solar panel on.
Sure.
So I designed it to be this very modular, very add-on friendly box, essentially. So I ended up using a material. I use PETG. If you don't use materials that are specifically targeted at UV, PETG is going to be your best case. It's got a really decent like UV compatibility.
Okay.
So I went with a material that I thought was really cool. A company called Greengate 3D, and they
Heard of
do.
them too.
Yeah, they're
Yeah.
they're really cool. They do entirely recycled filament, which
Right,
is
right.
primarily recycled filament, which is really cool. So it's made from industrial scrap.
Okay.
Um,
Yeah.
I'm always conscious if I can, I would like to limit the the amount of plastic out there. So
Sure.
it seems really good kind of deal for something like a mailbox. And then I started designing a lot of other things. So a mailbox has a door and a mailbox has a flag, and
Yep.
I tried to think of some other uses for something that would always be outside in my front yard. So I basically targeted like performance materials because I was really curious to get some real-time knowledge of how they react to weather and rain and sun and all those crazy things.
Yeah.
So I built a door for the mailbox entirely out of Oldham. It was a material we were playing around with the Centium at the time. It was actually gray. Oldham historically is this gold mustard color,
Yeah.
and
Yeah.
it's not sexy at all. It's a horrible color, but
Yeah. That's the natural color, right? That everyone
yeah.
thinks about. Yeah.
But for years, it was all that was available. Nobody put any work into coloring Oldham.
Right.
It was very practical material. You used it because you really needed the properties of it.
Gotcha. Okay.
So I did that because I thought it was cool. So I did a
Yeah.
white PETG mailbox, and then I did a door that was entirely Oldham. I did a flag that was PETG. It's this weird kind of 3D flag that I used a paint that was UV compatible with a UV clear coat to kind of
Okay.
test how that did. I've always been kind of curious,
Sure.
on some of these coatings.
Okay.
I used like one of the first experiments that I mounted to it was a weather station. So if
Yeah.
you go on,
Saw that.
if you
Yeah,
go
that's
on to
pretty neat.
Weather Underground, you can see how the weather is at my mailbox in Austin, Texas.
That is so cool. Yeah. Being able to connect to something like that, that's pretty neat.
Yeah, I thought that was super cool. So I did that. I used a really cool PEI based material called Duratem to do that because it was kind of tall, and Duratem's kind of shock resistant. So I thought somebody would come and knock it or something, and so I did something that would kind of support that.
Okay.
But I ended up putting it all together, and it's been out there for weeks. I've been getting mail in it, and been getting weather, and now
Doing
I'm trying to come
received
up
mail.
with,
That's good. That's a good
yeah.
thing.
Well, that was my biggest fear, was the mail company or the postal service would have been like, no, we don't
Right.
like this.
Right. Yeah.
And,
Well, I mean, you see people with like a fish head or, something like that as their mailbox, and you have to think
yeah,
that as long as it's a little latch door that people can put mail into, and you can put up a flag if you have something to put out, and it has
yeah,
to be just at the right height, at the right, distance
yeah,
out of
exactly.
the street. I mean, they shouldn't really care whether it's 3D printed or not, right?
So it turns out the post office has done lots of ergonomic studies about mailboxes.
Hmm.
So they have published a standard. So as long as you follow their standard, get the right height,
Yep.
you can use certain colors. So but the colors are very specific to be able to to use their standard, but the
Okay.
right size, the right door handle. There was a surprising amount of thought that went into what mailbox should look like on behalf of the postal service, which is kind of interesting. Like I didn't expect that at all.
No, yeah. I mean, you think about the ergonomics of someone being in, the car like that, and what's the easiest way for them to reach out of the car and
Yeah,
successfully put mail in the box without having to reach way out of the car, or, some weird contraption where you're trying to, actually be very dexterous, but most of them just have like a little latch to grab onto, right? That's kind of interesting
mhm,
to think about too. Yeah.
yeah. Somebody out there's job was to to quantify what a mailbox should look like.
That's pretty funny. That's awesome. I like the the way that you've made it modular too, to kind of accommodate these other things to it, so you could again potentially customize it to have your your door number on there, your family name on there, or something like that. Is that frowned upon in the the steps to build a mailbox, or did they have any kind of customization that people were saying no to?
No, they're totally, you're totally allowed to do names, door numbers.
Okay.
They're particular about colors, so they want the flag to stand out from the rest of the mailbox as a whole.
Yeah.
So I think that was their big concern for that. But it's been neat. I built a little device that sits on the top that holds material coupons, which was kind of cool. So I printed little samples of all these different engineering materials.
Yeah.
And it basically, they sit in there and then they get sun all the time. So I'm really excited. I know about how these materials should do, but it's going to be really neat to see, do colors fade? Do they become brittle? Like what happens to them actually?
And you've got an awesome science project going on right at your mailbox. That's
yeah,
sweet.
Yeah.
The pedestal that it's attached to, is that printed as well, or is that made out of wood? Or
I just maintained a wood one on that. Someday it would be neat to go crazy and just do additive for the whole thing. I imagine some kind of weird like generative design bracket or something.
That's pretty sweet.
I gotta wait till I get a metal printer, at the house.
Oh, there you go. Yeah.
Go for it.
Nice. Well, we're gonna have a pretty customized black belt here pretty soon. That's gonna be dual extrusion, extra wide build volume, and obviously printing continuously. So we could print something as long as and tall, I guess, then as a mailbox pedestal that you put something else on. So yeah, let me know when you're ready to work on that project. Let's do some work together. That's fun.
The dual extrusion, so you can do like support material and
sure. Yeah. That's the one nice thing about printing with a belt printer though too, is that you're printing at that angle, and it could be at about 45, 35, or 15 even. You can change the angle that you're printing at with this specific printer, so you don't necessarily have to have support material based off of where you're actually putting those overhangs, but could print supports that make things pretty interesting. But yeah,
dual materials. I mean, dual materials is the coolest part. I mean, you could do TPU combined with something rigid. That'd be really nice.
Right. Yeah. So thinking about all these applications, for different 3D printed things. I see you got a pegboard up on your wall there. Is that 3D printed as well?
Yeah, so that's a project that I supported on Kickstarter. I thought it was really cool. It's called Threadboard. Like, you should totally look it up. It's a cool project.
I think I've seen it briefly too. Yeah.
Yeah. So they did a really neat thing with their marketing. So it's a Kickstarter, but they don't deliver any hardware. It's all design files, which I thought was really cool. And then they also implemented a lot of like social media marketing. So they bought a lot of ad time.
Okay.
And I thought it was really neat. So they raised almost $150,000 for a project that's as simple as a pegboard.
Yeah.
And they just deliver design files. So that was really cool. But you basically get a zip file that's almost 1,000 parts, just all different variations of these boards. So essentially what they are, they're little holes and they're threaded. So you print these little bolts and then they slide in. So if you want to make some specific holder that holds your drill or something, it's easy to design, put the holes at the right spacing and then screw it right on. So I thought that's really cool. So I'm really excited about projects like this that people can do. And I thought that in particular that their ability to market it and raise that much money for just a clever design, I thought was a really cool like master class and what 3D printing could be.
For sure. I mean, there's so many people like that too that I feel like we could all learn from. And obviously, if they're putting some of these designs out there, they're also just helping with the adoption of 3D printing too, right?
Mhm.
Finding these practical uses for 3D printing, I think is really going to be key to it becoming even more mainstream and having, a chocolate printer in most homes, having different buying a printer instead of buying physical products from a store, I think is going to be
Right.
more interesting here as we create these more online marketplaces for buying things like that, the threadboard and different types of products like that. That's kind of where I personally see some of this stuff going is we have so many bright minds out there that can design different things like that, but then it's about how do we connect them down the path with like people that actually want to buy their products. What's the right medium for them to sell those products in? Do they sell
Mhm.
just the products? Do they sell just the design files and then other people can print them? What are your thoughts on that?
Yeah, it's interesting. Like when I started an additive, just the fact that we were printing things was crazy, and
Yeah.
and there was this huge push designing the actual hardware. But when you have printers that now have come out like the Bamboo, that's almost the easiest printer that I've ever used is process wise. So it's really an interesting time because now I think we really need to definitely up the amount of designs that are going out there and create these libraries of parts and things that people can print,
Mm-hmm.
which I think is really cool because I don't think everybody, not everybody has the mind for CAD and to be able to design things. So
Right.
I really am really excited about these marketplaces that create monetary incentives for people to solve problems and post things.
Right.
I think I saw one the other day that was really amazing. Like just add-ons for IKEA furniture because that stuff is so modular
Yeah.
anyway. It
Right.
was an amazing amount of like, they were able to take something from IKEA and absolutely change the way that it's used, or really augment the way that it's used using printing, which I think is really cool. And I think we need things like that to really to create an environment where the printer is a utility, in your house.
Right. Yeah, for sure. I mean, having that ability to, print stuff on demand as thoughts come to mind. And again, like you said, take advantage of those people that do know how to come about this thoughtful design process for printing purposes. Um,
Mhm.
and start to create this consumer aspect of things, right? Um,
Yeah.
I think, growing the consumer side of 3D printing where we go to something like Amazon or we go to the store, Target or some other pretty well-known store, and we know exactly what we're going to buy there, right? We
Mhm.
kind of have these preconceived notions about what the products are when we go in there and what we can use them for. And I think we're just barely scraping the surface for how 3D printing can help with that, right? Um,
Mhm.
so that's kind of something that I'm starting to work on a little bit. I do have this shirt here. Ask me about Arachnid 3D. Uh, check out arachnid3d.com, and
Mhm.
that's kind of this thought process of like, okay, let's create a marketplace for people to go to consumer wise. Let's create a space for where designers can go and show off their design files. Maybe they don't have a printer themselves, but they could otherwise just utilize their design skills and send
Mhm.
those designs to someone who would just buy the design, whether that's a company or a consumer. And then those people are printing it on site, within their own homes or within another business. I think something like that would kind of, start to break this other barrier of like, what do we do with 3D printing in our own lives? Like I 3D printed a set of floating shelves for myself.
Mhm.
I've got a floating shelf design. I've got a garbage can design that we've printed as well. So like very useful, thoughtful things that can be printed in otherwise and used in our homes, like
Yeah.
the threadboard behind you. Yeah.
I mean, I always thought automotive would be a really good segue into that. So you've got like, I think out of anybody, Ford did the marketing on the Maverick truck, where essentially they released some parts that you could 3D print. But it always bothered me because if you look at the Maverick, they've got like one or two of these just slots, these V slots that you basically, it's pretty much only for a cup holder or something like that.
Okay.
But I really think that like automotive can go a lot further because that's an area where you break things constantly, like
Sure.
little pieces of door trim break. I've got an electric Mustang, and there's a tiny community has been kind of propped up because it's got a lot of these plastic parts that break. So there's been some companies that have come through and they've just scanned and released the scan files for
Okay.
replacement parts. For example, on the front of this car, it's
Yeah.
got these air flaps that open up to decrease like drag on the part or on the front of the car. But they're these really small plastic flaps and they're really low to the ground. So if you hit a tire or you hit something on the
Yeah.
interstate,
Yeah.
shatter. And these parts ended up being, a few $100s to
Oh yeah.
replace this tiny part. So everybody's been printing them, and it's been this great thing. Somebody just scanned one of them one day, and then people have been loading them up on the printer and just replacing them. And I think that's like such a great application.
Yeah, for sure. I mean, anything that's going to be, broken one day and designed and printed the next. I mean, that's definitely where things are definitely going. I had a woman come in the other day who had broken a part for her drawer, kind of an antique kitchen drawer set. So she wasn't
Hmm.
going to find the part anywhere, right? But she had the other side. So we were able to reverse engineer it and, print it out of PLA in a matter of an hour. And she, this was kind of the first instance where we went from, initialized design in a half hour to printing in an hour. She comes back after lunch and she has her part and she goes home with it, right? Uh,
Yeah.
that's a pretty neat, application for printing too, I think. And, I had just 2 weeks ago, there was a gear in my garage door that was broken in half for whatever reason, just split, probably fatigue over time.
Hmm.
Went on the company's website. They didn't have that specific part as a replacement part that I could purchase. So what did I do but reverse engineer it and print it? And now it's working perfectly fine. Otherwise I
Yeah.
would have had to replace the entire, unit, garage door unit. So I think it's a really neat, way to utilize printing. Yet, people don't quite have those design skills like you and I to be able to do that. So yeah, kind of finding those instances to be able to put that out to the community, I think is pretty powerful.
Yeah, I think that's really cool. That's a world that I want to live in, right? From a
Yeah,
sustainability standpoint.
sure.
I've got tons of products that I just love this product, and maybe one thing breaks, and then they just don't, it's not made anymore, so you have to replace
Right.
it.
Right.
So I just love that idea of having these, sort of modified parts everywhere. I think that's like really cool. And
Yeah,
I think it's a real cool area for like design software too. I don't think a lot of attention sometimes gets paid to
sure.
these design tools, but as AI comes, to fruition and things, I think being able to replicate parts, I think is going to be a lot easier too.
Yeah, definitely. I mean, it's only going to be a matter of time where you just speak into a bot like Chat GPT or something and
Hmm.
outspits an STL file to print, right? I think there's
Yeah.
something pretty similar to that where you don't like just kind of prompt it to do anything, but you type in, from a library of things they've already designed, and you can just have that STL file like prepared for you. I forget what company that was that kind of creates the STL file on demand like that, but yeah, I think we're kind of starting to move in that direction. Um, what do you think they could do about, printer settings? Because I think that's like the next bane of existence of 3D printing is that like, well, okay, I've got this file that, person A printed just fine on whatever printer, yet, I only have the STL file and not the G code, or it might be a completely different printer, so how do we kind of help fix that? like knowledge gap of printer settings, what would you do?
Yeah, that's a difficult problem. That's one I've put a lot of work in. You know, especially at Ascentium, being able to, because sometimes even the printers themselves, you know, have this one prints better than this one, and you have
Right,
to quantify why does this printer, they're the same model, you know,
right.
why is one getting better results? My thought is that it really comes down to printer calibration. So
Mhm.
I think the best consumer level printer, and I've said this a couple times, but the Bamboo Lab printer,
Yeah,
one of the things that they do is resonance calibration. So it vibrates the machine, and then it tries to counteract the amount that the machine vibrates. And I suspect that that has a lot to do with why the parts are so good.
right,
I think really pushing these technologies that calibrate and monitor all the processes of the machine would go a really long way of creating processes that work across, you know, multiple machines. Because
hmm,
the problem with 3D printing too is you have so many different levers to turn. I
right,
mean, brand of material is a big thing. Like what is the quality, and you know, the variance and diameter as it goes, you know, through the machine.
right,
That's a big thing. You've got nozzle size, you know, all these different processes
right.
um, that come into play.
Yeah,
So I personally think that printers need to learn to quantify and understand what's happening as material goes through, to be able to get that better.
right.
Because I think with the technology the way it is right now, it's going to be up to the specific user and their experience of dealing with and noticing, you know, why something is happening.
Right, right. Yeah, having that last part, knowing why something is going wrong and then knowing how to fix it, or
Yeah,
at least one or two pathways to fix it, I think is definitely that missing link.
because
Um,
you're relying right now, you're just relying on experience versus
right.
hardware.
Yeah,
And if you could rely on hardware, I think it would be easier to quantify for sure.
right, absolutely. So with the bamboo, so I've been looking at it for a while now. Definitely intrigued by it, and it's multi-material, or multi-color at least
Mhm.
capability, right? Um, am I right in the fact that they have their own slicer program that's just for their printer, right?
So it's sort of it's still Prusa slicer, and they
Okay,
basically created their own flavor of Prusa. So it's
okay,
a fork of Prusa.
okay,
And most of the additions that they've added to the Prusa slicer have
yeah,
been in the form of UI changes. So it's
okay,
easier to
sure.
use, but I think the underlying technology is still very much influenced by Prusa.
Okay, interesting. Yeah, I love Prusa Slicer. Use it quite a bit. Use a bunch of different slicer programs depending on which printer I'm using. Um,
So you
but
don't find, because I find that too. Like for me, like
yeah,
people ask slicer I use like seven of them,
yeah,
and it
yeah.
just depends on what I'm doing. You know.
Prusa Slicer, Simplify 3D, Cura, Idea Maker, Raise 3D. I mean, I think I say that not every slicer is created equal, that, different slicers have different settings. And for whatever reason, those settings work a little bit better with their own printers, right?
Yeah,
So, like, I'm
yeah,
not going to use Idea Maker from Raise 3D for my Fill and Innovations Kratos. And yet again, the printer companies are looking at trying to help more fine tune some of those print settings that maybe are a little bit more abstract to think about. So like Fill Innovations just came out with a beta version of their software um, that's called Odin, and they got the whole Greek mythology going on there.
yeah, yeah.
Pretty awesome stuff. But so there's a company from Denmark, Create It Real, who's doing a lot of custom slicing, capabilities and building out these UIs. So Odin is one slicer specific to that printer. I think that might, and again with the bamboo instance, they're trying to take some of that guesswork out of it, right? Uh,
Hmm.
and trying to make that a little bit more plug and play for the user.
Yeah.
Yeah.
It comes back to that, like the old argument from the early 2000s, 90s, you know, Apple versus Microsoft, you know.
Right.
you're always going to get better performance out of a closed system, but you're going to get a lot less freedom. And it's you've seen the same thing with Stratasys and
Yeah.
companies like Ascentium too. It's you have to decide what you want to do. One of the areas that I think is like a really good compromise is I think 3D printer companies, a lot of them choose to design their own hot end, and that hot end geometry really affects the process of printing.
Right.
So I really like to go towards companies like E3D or Slice Engineering,
Yep.
because I think that does a lot to kind of equalize the results that you're getting. At least if most companies are using similar nozzle geometry, that eliminates a large section of the problems or the unknowns, basically.
Right. Right. Yeah, and you're getting different, print qualities out of different setups like that too, right? Because some of those
Yeah.
hot end materials aren't all the same. They're aluminum, they're stainless steel, they're
Mhm.
brass, they're, a bunch of different, capabilities and different ways to set up a system. But then you've got, like instance, Raise 3D has their own nozzles for their own machines, and you can't
Yeah.
really put a Revo, hot end on a Raise 3D printer. So while that's limiting, I understand why they're trying to limit some of that, where they're trying to make it easy for the people to use the machine.
Well,
Uh,
it's still a revenue stream too, though. You
yeah,
make your own
right.
nozzle. You're the only one who does. It's still a consumable thing too.
Yeah,
But
exactly.
but, but I would push, like I get frustrated with that, and I would push additive companies to really adopt
Hmm.
these third parties. Like the Revo system's so great because there's a huge amount of nozzle variants,
Yeah.
and then you've got the high flow ones, and you've got the abrasive ones, and I would love 4 or 5 companies to make these hot ends, and then every printer to go out and use them. I think that would be cool.
For sure. Yeah, I haven't
Yeah.
used any of the Revo hot ends yet myself, although they look pretty intuitive to use, right? I think it's one of their reasons for coming up with that design was just a simple change mechanism, right? Of
Yeah.
changing the nozzle and making that a little bit more safe for people, right?
Yeah, so we're talking about my I was talking the other day. My nephew is just starting to get into 3D printing, and we're talking about what printer would be best for him. And I one of the things that I think is great about the Revo is historically you have your filament path from the motor. You've got your heat break, and then you've got your heat sink, and then you've got the nozzle itself, and all of that.
Mhm.
And all of a sudden, that entire nozzle is one single filament path.
Mhm.
So for my nephew, who's not the age where he could, unclog a nozzle and drill
Okay.
out a nozzle,
Right.
it would be great because you just unscrew the entire filament path and then put a new one in.
Mhm.
So I really like the direction that they've gone on that, and I like that they've paid attention to those of us using like carbon fiber filaments
Yep.
or wanting to do large layer heights and do high flow. I feel
Yep.
like they haven't really left anybody out of the fold, which I think is really cool.
Neat. Yeah, I'll have to look into that a little bit more. Just started a reseller relationship with E3D, so that's been
Oh,
cool
nice.
that partnership with them. I do resell materials, some materials that we use here at Ascent Fab, just to help again people like find what are good materials. If they work and they work consistently, have those as a resource for people. And then I'm constantly getting some consumable equipment. So E3D has been, my go-to for that as well. And then looking at some of those printers that, I know work pretty well too. So having the relationships with the printer manufacturers that we do, like Thulin Innovations, and then on the low end, I really like the Artillery Sidewinder X2. I just
Mhm.
think like right out of the box, it's so simple to set up for people. It's got a large build volume. It checks off a lot of the boxes, maybe not all the boxes, but for someone who's looking to get, into 3D printing for $300, really a pretty nice out of the box printer.
Mhm.
Can be used for months at a time and doesn't have too many issues with it. But yeah, love this kind of, education that's going on right now, around trying to have younger people being in 3D printing. Yesterday I had a 10-year-old in here, that he brought in his Ender 3, and he's like, it's broken. I don't know, I can't do anything with it. Just take a guess at what was broken about the printer.
Was it probably clog or thermistor out?
So it was close to clogging. So basically, it was just a Z offset issue and bed leveling, really. So the Z offset was just too small, so the nozzle was right up against the bed and effectively scraping the bed. And the bed was definitely unlevel as well. But back pressure up into the nozzle, so he wasn't getting anything printing. And he's like, oh, but I noticed something on this this screw back here next to the motor, at the extruder. And I'm like, yeah, you see the plastic getting built up. And he's like, but there's nothing coming out. I'm like, well, yeah, we have to look at what's happening down below in order to figure out what's happening above, right? So I love that kind of hands-on teaching, of that kind of younger age to see the gears turning in their heads about like what can they use 3D printing for.
Oh yeah, I think that's so cool. Like I mentioned before, like I was the last generation that like grew up without additive, and I think about all those crazy projects that I worked on trying to figure out how to build things, with like I made my lathe, and it's what could I have built if I had additive? Like I just
Right.
I wish I could go back in time. Like here's an Ender 3. Good luck.
Right. And now for the next 30 years, you're going to be on the moon printing, right? So
Yeah. Yeah.
that's the goal. That's the goal.
It's funny when you talk about like small problems. Like I used to live when I lived in Vegas. I lived by like one of those Amazon warehouses that would they would get returns and they would auction it off. They got so many like Creality Ender 3s and stuff, and I needed just throughput because I was printing so much. So I needed extra printers floating around.
Yeah.
And I would go there and I would buy a printer for $50. It was almost always like the thermistor was out, or it had a little clog, or like calibration problems. It was just something simple. And
Right.
almost always I'd have that printer running, in an hour or something.
Yeah.
So you're definitely, you hit it when you asked that question too. It's like, how do you get to the point where people don't have to deal with, those problems.
Right. Because I think a lot, again, people are interested in 3D printing, but what is going to be the time to market for this educational side to really uptick? It's so there are a lot of 3D printers now in high schools already. My local high school has had 3D printers since right when I graduated high school in 2011. So right after that, they started to get into 3D printing. They had laser engraving, right? But but they didn't have a 3D printer in 2011. So they're in high schools, they're in some middle schools now. That's definitely a great age for people to be getting into it. But then, once you get into college again too, it's like, okay, well, you aren't otherwise going to use it unless you're taking a course that's using it, or if you're not working for a company that's not using it. And then you fall into the other bin of like, okay, I'm just but I'm a consumer level and tinkerer here in my own time. So I think that's like, again, the need for education and like that kind of outreach, I think, has to happen in some other way too, in a communal fashion.
Yeah. Well, they need to start CAD early. I was always lucky. My dad was designed CAD software when I was growing up. So at a really young age, I had access to CAD and being able to design things. And that was always super useful. So like I know it's possible, and I feel like you should almost offer CAD as like a language credit. Similar like programming, right? You can take German, take Spanish, take CAD, or take Python or something.
Makes sense to me.
Yeah.
Yeah.
So, I mean, that definitely, it's like it's a steep learning curve, because it's not just the printer, but it's definitely the software design standpoint too.
Right.
It's funny, like you talk about 2011, like when I was in college. So I graduated in 2011
Yeah.
from college,
Yeah.
and we had a printer on site, and it was a tiny SLA printer, and it was in
Okay.
one of our professor's office. I never saw it in the 4 years that I was there.
Yeah.
I could send him an email to print a part and then slide cash under his office door to cover the cost of the
Yeah.
part, and then the part would arrive on my desk. But so I was never plugged into any of
Okay.
the so it's really cool for me to see, like, high schools having it. I think that's like so great, so different from
Yeah.
when I went through.
For sure. Yeah. I mean, I was in college my senior year in my undergrad in 2015. So again, it was until my senior year that the college purchased a 3D printer. It was an Ultimaker 2, and so they're at that consumer level, but on the higher end of the consumer level already. And my senior capstone had to be focused on like an individual project, and my mentor said, well, we have this 3D printer thing down there in the basement that no one's used for the past few months. Go down there, figure it out, and do something with it. So that's kind of my introduction into 3D printing. Was a crash course on my own, completely self-taught in that
Yeah.
respect. I think that's, one of the best ways to learn too, though, is just kind of figuring it out and trying something out, seeing what's working, what's not, and see how you can fix it.
Yeah, it's a great way to learn, but I also think, especially like universities, like I feel strongly that my university, I went to Auburn, and
Okay.
I feel like we should have adapted 3D printing early.
Yeah.
And and I think most universities did probably a pretty poor job of bringing additive. Like, as soon as MakerBots came out, that should have been it. They should have immediately bought 4 or 5 of those, and then
Right.
and then saw how it went.
Mhm.
So I think that's really neat. So I think, like, I'm a big believer, like the whole education system around additive needs a little bit of a facelift. But
Yeah. I mean, to see where they've come in, 12 years, even the last 8 and 5 years, I think a lot of that consumer level printing has just skyrocketed.
mhm,
And we're barely touching the surface. Um,
yeah.
there are so many other use cases for 3D printing that, we just even haven't even thought of yet, or haven't had the need to think of it, right? If something breaks, maybe then we'd think of trying to print that part. But then maybe we're getting into the next stage here in the next few years where more companies are saying, well, why am I not 3D printing this part already? And
Mhm.
making that a little bit more modular and easier for people to replace too. There's a lot less inventory to carry. Some of the benefits could go on and on for it, but I'm really excited about, I'll say the next generation of 3D printers and designers coming out, because they're going to influence this so much to where the possibilities are endless.
Do you feel like we're in? So I separate it. So, like, you have a lot of the guys who worked on printing in like the late '80s,
Yeah.
with 3D systems, creating like the STL format in like '87. You've got a lot of the guys who were doing it in the '90s, but I feel like there was a real, like, next generation of 3D printing. I think really started like with the MakerBot in like 2012 or so.
Yep.
Do you feel like we're in like another round of a generation, or do you think it's kind of a continuation?
Yeah, I think we're in a new round from when I started to get into 3D printing in
Mhm,
2015, even, because now these consumer level printers are just getting better and
mhm,
staying pretty cheap. Um, so I think because of the, updates to the hardware and to the slicer programs, I think we're starting to get to a point where more people are being able to adopt 3D printing. The 10-year-old that came in yesterday, he was just on Thingiverse and, looking around at files that he could download and print, and I had only had him in here one time before this. He got the printer for Christmas this year, and but right before that, I had him into the office and showed him one of the coasters, our logoed coaster that I print out as a giveaway for people. He was just kind of wowed at that fact that himself at 10 years old could do something like that, could create something like that. And because this generation is so much more digitally oriented even than my generation is already, I think we're at a point where the adoption rate's only going to go up too because of social media. I lean pretty heavily for inspiration on people like you that are active and posting a lot to show people what's possible, right? So that's what I'm trying to help out with too, is just show people what's possible. How do we do this? How do we think about going about that design process? Because I think we're in a pretty pivotal stage here where we're going to start to see a lot more 3D printing happening, just in our local communities too.
Yeah, that's very cool.
Yeah. But yeah, with that, there's been a lot we've talked about, going from aerospace to chocolate printing to consumer products like, the threadboard that's behind you. I really enjoyed this conversation, Zach. I appreciate your time, man. And, looking forward to chatting with you a little bit more. I saw you post recently too, that you're going to Form Next, right? Pretty soon here.
Yeah, Form Next Austin, right down the road. Yeah. So if anybody listening, see me walking around. I usually have like neon green hair and that deal, so I should be really easy to
Sure. Yeah. No, I love it. I love the glasses too to match with it. Those weren't printed, were they?
I have a printed pair that I wear. So I started off on the neon green hair, and then as I was posting stuff, I started to kind of get known for it at like trade shows.
Yeah.
So I just kind of like let it spiral out of control, and I pretty much buy everything in neon green now. Makes it really easy to find me. So if you see me at Form Next, reach out. I'll hang out a bit. But
yeah, awesome. I didn't see it that early enough that Form Next is going to be happening there. So I definitely won't make it this year, but looking to get there next year, and some other more additive manufacturing conferences.
Yeah, it's a good one. AMUG's a great one. Rapid's always fun. And
there's the Rep Rap festivals too.
Yeah, I haven't been to the Rep Rap festival. I'd love to go. So that's on my list. Probably next year I'm gonna try to hit that one.
Yeah, I think that's coming up in October. I think is it in Maryland maybe? I think
I don't remember.
Down around there. I think it's in Maryland. So we'll definitely check out some other conferences that could be useful for people and mention those a little bit earlier on. But yeah, have fun at Form Next. Hopefully I see you at another 3D printing conference here soon. And looking forward to chatting with you a little bit more.
Yeah, awesome, man. Thanks for having me. It's been fun.
For sure. Well, thank you to everyone for listening to Fabrication Friday this week. Had a lot of fun with Zach. Looking forward to more talks coming on. So have a great weekend. Thank you very much for listening to the Fabrication Friday podcast. That conversation with Zach was a really fun time, and I'm really appreciative of his time to be able to share with us all the really cool things that he has been able to do within 3D printing. I wanted to get into the tech tip of the week. Tech tip of the week is relating to our Van Ness prosthesis, actually. So Monique wanted the flexible inner for the thigh section here to be printed originally in two parts, so that the two parts could kind of nest into one another and just kind of overlap slightly on those edges. So I did, share some concerns with her about that. I wanted to print it on the artillery sidewinder. Once you start to print with flexible materials a little higher up on a printer like the artillery, where the bed is actually moving and there's only one Z-axis gantry going up and one crossbar, you do have a bit of Z wobble. So you have the part actually physically moving. We'll show a video here of the part moving where the nozzle is actually moving material around the print, and because the material is so flexible and you're so high up, a very little amount of force can actually move that part on the plate itself and then cause, print issues. So this is kind of what the pour print looked like. And so I showed that to Monique and said, look, I really want to print this a different way. But what's going to happen is, because you're going to want to split this in half and then kind of skive the edges to overlap the parts, I'm going to print 2 of them so that you can have a front half and a back half. And you can very intimately mate those together. So ended up printing it, like I said, on the Kratos with the 0.9 millimeter nozzle, and the print came out beautifully. So our tech tip of the week this week is watch out for Z-wobble. If you have a flexible material that is a fairly tall print, you might want to consider a different printer to print that on, or consider some external structures that would help this part remain stable along those very outside edges. Could end up being just a very thin section of that same plastic, that TPU, that you just create kind of like this fanned outward, rectangular structure on the edges of the part itself, in order to try to stabilize those edges a little bit. So thanks for listening in to the Fabrication Friday podcast this week, everyone. We'll see you next week.